Where do we start when trying to explain something as big as the universe?
Can one concept really be applicable to everything we can observe?
We found the answer from a woman obscured by the dark. In 1915, while Einstein revolutionized gravity, a woman changed the world of modern physics through her work on symmetry. Symmetries are everywhere we look. But for Emmy Noether, they aren't just about aesthetics. In physics, whenever there's a continuous symmetry, there's a conserved quantity. There are three classical conservation laws that emerge from these symmetries. Conservation of momentum from translation of symmetry. Initially, only the left cart has momentum, but as it hits the right cart, it transfers its momentum to the other cart and stops moving. The total momentum of both is the same. Conservation of angular momentum from rotational symmetry. Notice, as my arms come in, the radius decreases, but my rotational velocity increases. Therefore, angular momentum must stay the same, and conservation of energy from time symmetry. As the apple goes up, it's slowing down and its kinetic energy is decreasing. However, its potential energy is increasing. Throughout the whole path, the apple's energy is the same. But even if there's no symmetry, Noether's theorem still gives us a way to uncover the hidden rules of nature. One of the biggest puzzles physicists wrestled with
is why objects have mass.
The answer came from Peter Higgs. Here's how it works.
Some particles like photons glide right through. No resistance, no mass. But others, they get bogged down. The more they interact with the Higgs field, the more they resist acceleration. That resistance, that is mass.
Even in the case with the Higgs mechanism, where there's broken symmetry, Noether's mathematical structure still provides a foundational, universal framework that allows us to understand and simplify nature. It begins to sound like a theory of everything, so why don't we think about Noether's work as a prime example of one? Her brilliance has been left in the shadows for far too long. Maybe it's time we finally turn on the light.